History has its moment that splits time into before and after. From the invention of the wheel to today's astonishing strides in space exploration, milestones shape our journey. SpaceX is at the frontier of these moments. In December 2015, they achieved the unimaginable, turning what was once a wild dream into reality. They launched a Falcon 9 rocket into orbit and then brought it back to Earth, safe and sound. Imagine that, launching a rocket and reusing it, much like how we drive cars back and forth. While many have been shooting rockets to the sky for years, none ever thought to bring one back. Why did SpaceX succeed where others hadn't even dared to venture? Was it all due to Elon Musk's brilliant mind? Perhaps. But there is a more gripping tale behind how SpaceX reinvented the rocket, and it's a story worth telling. Let's delve into the details and explore the exciting journey of space exploration that lies ahead. At the heart of SpaceX's success is its pioneering reusable rocket concept. This feature sets them apart from other players in the aerospace field. It's a concept that completely transformed the way rockets were perceived and utilized. Yet this notion might seem a bit difficult to accept at first glance, right? After all, someone must have realized at some point that it's far better to recover and reuse these massive rocket boosters instead of simply discarding them into the ocean. We've seen something similar with the reusable aspect of the space shuttle, haven't we? It's interesting to note that Blue Origin, another company in the industry, also has a rocket booster with the ability to land like SpaceX's Falcon 9. You might hear some important people in the space airplane industry saying that rockets you can use again aren't really cheaper or better for the environment than the old way. So, what makes SpaceX's different? To solve this puzzle, let's start from the very beginning and explore how space travel started. The early rocket that could launch payloads into space were essentially modified intercontinental ballistic missiles. A prime example is the Titan II, originally designed to carry a nuclear warhead across vast distances. Interestingly, it ended up being repurposed as a launch vehicle for NASA's Project Gemini. This shows that these rockets had limitations, and we couldn't expect them to do everything. For the monumental Apollo missions to the moon, NASA engineered a specialized rocket known as Saturn V. This colossal rocket was larger than any other in history. But here's the catch. Only the tiny crew capsule safely returned to Earth. Everything else was either abandoned in space, coincided to the ocean's depths, or left behind on the lunar surface. Although this might seem wasteful, NASA had its reasons. The Saturn V was designed with the intention of flying a limited number of missions. Consequently, it was deemed more cost-effective to create 12 disposable rockets rather than invest in a single reusable one. However, the engineers at NASA had their sights set on the future and were contemplating revolutionary ideas. The concept of the space shuttle, a rocket plane and booster system that could be fully reused, was in the works well before humans ever set foot on the moon. Wernher von Braun, a key figure at NASA, had been refining this idea since the mid-1950s. It's worth noting that von Braun had an intricate history tied to Nazi Germany, which is a fact we've come to understand better in hindsight. Regardless, the concept of the rocket plane was envisioned as a means to make space travel accessible to the masses. The ingenious design involved the rocket's first two stages returning to Earth with the help of parachutes, while the orbiter stage would glide back to a runway landing. This would render the three-stage rocket fully reusable. It's fascinating to consider the evolution of this concept and how it eventually culminated in the final stage of the space shuttle. When we talk about the space shuttle, describing it as a vehicle designed for refurbishment rather than pure reusability is more accurate. However, you might wonder, why does this distinction matter? If you observe airplanes, they land, unload passengers and cargo, undergo a quick turnaround of cleaning, restocking and refueling, and then take off again. All this happens within a relatively short time frame, usually an hour or so. This demonstrates that airplanes can indeed be used multiple times in a particular manner. But what if the airplane had to be completely taken apart, inspected, serviced, and reassembled after every single flight? This approach wouldn't be viable for any airline business model. NASA faced a similar dilemma with the space shuttle fleet. While the shuttle initially met the requirements set by the US government, it ended up requiring an immense amount of work for every flight. Congress funded the shuttle project in 1972, and the process of preparing a shuttle and its twin booster engines for another launch after just one flight demanded an astonishing 650,000 hours of combined labor. If each step had to be performed sequentially, refurbishing a single space shuttle would take an astonishing 74 years. Clearly, the value of reusable rockets hinges on how frequently they can be launched to justify the investment in their technology. This brings us back to the earlier point about NASA's decision to opt for 12 disposable rockets instead of a reusable system. The crucial question emerges: when does a rocket with multiple use capabilities become financially practical? How many launches are needed to make it worthwhile? Surprisingly, even NASA, the space agency with extensive resources, couldn't definitively answer this question. The fate of NASA's space shuttle program was somewhat doomed from the start due to higher than expected maintenance needs and a lower flight frequency than anticipated. It turns out that disposing of each shuttle after a single mission and starting anew might have been more cost-effective, if not cheaper, for NASA. Aside from being the most expensive rocket ever crafted, the space shuttle also carries significant risks and ultimately fell short of achieving its intended objectives. Since NASA struggled with the concept of reusability, it's reasonable to assume that other entities faced similar difficulties. This paints a comprehensive picture of the intricate landscape of space exploration and the hurdles that must be overcome to achieve true reusability in the realm of rockets. Then there's SpaceX. They said they could do something tough that others couldn't do. But to be fair, they did things in a new way. Their Falcon 9 rocket is different from NASA's shuttles, and it makes more sense. They wanted to make parts of the rocket come back to use them again. They tried to make the first and upper parts come back after they have launched, and they did it by making them land. They didn't try to save the upper part later on. It's not as important as the first part. They tried to make the first part land using its engines, not parachutes. Parachutes are like big cloth bags that help things fall slowly. They worked for the space shuttle because those parts were light and simple. After they used up their fuel, they were just tubes. But the Falcon 9 booster goes really fast and high, so parachutes can't help. The booster has a lot of energy, and that's not good for parachutes. It's like when you run fast and hit something. It's a lot of power. SpaceX thought of a cool way. They used the booster's engines to slow down instead of parachutes. The engines also keep it safe from the heat when it comes back. The booster does cool things like spinning and slowing down, then it uses fins to guide it. The engine fires again to land safely. SpaceX did this more than 100 times. But it wasn't easy. They had to try many times and change the rocket before doing it right. The first one, the original Falcon 9, was short and not as strong. It couldn't come back. Then they made a better version, the Falcon 9 version 1.1, with more power and legs to land. They tested it many times and improved it. Then they made the Falcon 9 full thrust, even stronger and better. It landed safely and made history. Now, let's talk about the Falcon 9 Block 5. It's as big as the old one, but has an extra 200,000 pounds of push, making it 1.8 million in total. It has black legs and a middle, so you'll see that first. The main goal? Make the rocket fly many times. Remember, there is a difference between fixing and using again. SpaceX used to fix their Falcon 9s, but didn't fly them again. In March 2017, SpaceX flew a fixed Falcon 9 that was used before. After use, they found tiny cracks in their engine. So they changed the Block 5. They made stronger side fins from titanium instead of aluminum. These were really expensive because they were the biggest ones made from one piece of titanium. This helped control how the rocket flies and gave more shield from the hot re-entry. They put a shield on the whole Falcon 9 to reduce heat. They also added a new cooling shield at the bottom. Now, the legs of Block 5 can fold and unfold. Before, used legs had to be taken off and thrown out. The Block 5's tanks are stronger and have carbon fiber inside. These tanks hold helium gas. 2 older Falcon 9s exploded because of these tanks. 5 years after making these changes, what did SpaceX see? Can the rockets fly again? On July 10 this year, the Falcon 9 called B1058 flew and landed for the 16th time. The first people on a SpaceX flight, Doug Hurley and Bob Buchanan, flew to space on this on May 2020. So it flew 16 times in 3 years. At the start, SpaceX thought the Block 5 could fly and land 10 times. They thought it could fly 10 times in 2020, then 15 in 2022. Now, B1058 can fly 20 times. SpaceX thinks Block 5 might fly and land 60 times because of these tests. The Discovery shuttle flew 39 times, the most back then. Shuttles flew 5 to 8 times a year, with 135 flights in 30 years using 5 shuttles. So we don't have much to compare, but data shows Falcon 9 is a really good rocket to use again. Now, we just have to wait for the next big thing. Will the Starship be the next step in reusable rockets? Let us know in the comments. Smash that like and subscribe for more.